I was trying to diagnose this twerking problem, and you'll see in video part number 2 what happens with the generator. So I checked everything and I came down to, you know, could it be the CRT doing this? So I grabbed one of the other sets, and it is in fact the CRT that's causing this problem. 100% the CRT. You can see there's absolutely no shift here. It doesn't matter what I do with the contrast. The brightness all the way up, there's absolutely no shift. So it is a bad CRT. Some kind of defect, some gassiness, some air in the CRT. And you can see how much better the linearity is here, and how things don't shift around, and how there's no smearing. Okay, check this out, David. Here's a brightness control right here, right? It's basically just a bias for the cathode. And then the, where is it? Where is this stupid thing here? Come on. Anyway, here we go. Anyway, here's the contrast control right here. Right, so it's kind of like AGC a little bit, because this is an AGC feed right here. Let me see, right off here, this is an AGC feed. Which does, the AGC is working, because I flipped that local distance switch. It doesn't, you can see it like shift and then it comes back. But anyway, okay, here's a contrast control, so it drives the amount of gain we have here. Okay, check this out. Now I got the brightness turned down really low. All I'm doing is adjusting the brightness. See what that does? Okay, here's the contrast. Now that it goes away too with the contrast. Okay, here's the brightness. Okay, I'll be there in a second. How could the brightness affect this? How is that even possible? All the brightness does, is adjust the voltage here. You know, it's isolated. It's isolated by this capacitor, which I'm 99% sure I changed. Maybe I better check that. Maybe it's hiding somewhere. This is the chassis out of the red TV, the one with the picture tube that's working right, with the yellow TV chassis that I recapped and restored and went through in it. I'm going to take this chassis unrestored and couple it. I don't know if this chassis works. It looks to be very low hour compared to the one I restored. I couple it with the CRT, the rebuilt CRT that was having the shifting issue, and see if this will work well enough to produce a picture and show the same shifting, just to prove the point that the problem is the CRT and not the chassis, even though switching the CRT fixes the problem with the other chassis. A lot of people still want to believe it's capacitors. Capacitors are the fault of everything, and nothing else can ever go wrong with a piece of vintage electronics except the capacitors. So let's try this. And of course, if this doesn't work, then this video will never be posted, so there's no point to really go any further with the description. I took the CRT out because I have a feeling this is not even the right tube for this set, and I can't find any numbers on it. This is the only sticker that was on it right here, and there's absolutely no numbers on this thing at all. And I noticed that the bell is shaped a little bit different in the one with the GE tube. So I have a feeling that this is the wrong wrong CRT for this set. Okay, this is the CRT that is shifting that I suspect as being defective, or the wrong CRT in the low hour unrestored chassis. And of course I cannot get the vertical to run at the right speed because the capacitors are bad, but you can see the shifting there. And you can see as I turn the brightness down, the shifting goes away. You can see as I turn the contrast down, the shifting goes away. Definitely the CRT. Let me see if I can adjust the vertical size or whatever and get this thing to lock in. Capacitors are too far off, but there's no way I can get it to lock in. I can show you exactly which capacitor's off too. That one right there. That's the feedback cap that screws with the timing. So there you go. CRT and another chassis does the same thing. You can even see it down here. Torquey CRT Part 4. This is something that came up in a conversation between Bob Anderson and I, and also in the comments. And I actually, it seems logical enough to me to where I'm willing to take the time to put this whole damn thing back together again and actually see if it is the problem. And what we're going to look at is low capacitance of the CRT itself. The CRT has the DAG coating on the outside, and it has the coating on the inside which is attached to the high voltage, and the two with the glass in the middle create a capacitor, and that capacitor is responsible for filtering the ripple out of the high voltage, which would come from the half wave rectification and that. So this CRT looks to have, you know, a really robust coating that's not flaking off at all. I was tempted to clean it, but then at the same time I didn't want to, because I didn't want to risk cleaning the coating off. So what I'm going to do is I'm going to try and measure the capacitance on this. I'm just gonna, this is where the TV holds it, and I'm just gonna, I don't know if I can hold the camera at the same time. Let's see. So I'm just gonna hold that on there. You can definitely kind of see. I don't know, this is a little bit flaky. You definitely see something when I connect it there, but it's really hard to. Let me try and do this without the camera. Okay, I got it all set back up. I was unable to get any capacitance reading off of the CRT, between the CRT, the outside of the CRT, and the anode connection. There was nothing there. So what I've got here is, of course, I had to hook it back up and get the ion trap back on and get that in position. What I've got here is a (102). So this is a 1000 picofarad at 15 kilovolts, and I just got this tied to ground, and I am just going to touch it here on the high voltage. Holy crap, look at that. That's the problem. And that makes logical sense, because as you increase the load by turning the brightness up, you need more capacitance to filter off the noise. So maybe this DAG is, I don't know though, it looks good. But maybe it's on the inside it's no good. But I have no way to test that. But that straightens it right out. Let me disconnect that capacitor. This right here, this would give you a nice shock right now. Let's see what happens here. Oh yeah. Stick your tongue on that. Okay, well, 2 people win the award on the fix, and it's this. I'm not even going to try and say this right here. And then, of course, B. Anderson TV. I was thinking ripple in the high voltage supply from a bad conductive coating, but the conductive coating doesn't look I mean, I've seen CRTs, especially the 10 BP4s, where the DAG is just gone. I mean, there's just like splotches of it on there, and I know they use slip plate to fix that problem. But yeah, there was a good conversation here on this, and so yeah, it was the CRT. That was a correct diagnosis on my part, but the actual problem with the CRT is the coating or something causing it not to filter properly. Notice how this changes the sound. Hear that? That's with it disconnected, and I'm going to connect it. Yeah, that's the 680. Come on, focus, you stupid thing. High voltage ripple. It actually seems to like the two of these in parallel a little better if you listen to the speaker. And you can see a little tiny shift in the line, so I gotta just figure out where I'm gonna put one of these capacitors. Okay, I cleaned a section of this off good, and I am ohming it out. And there's nothing at all. I think this is black spray paint. This doesn't have that shiny sheen to it, that kind of carbony, what do you call it, that graphite-y looking sheen that Aquadag usually has. I think this is black spray paint. I was wondering why this CRT was a little bit on the dim side. This is the good CRT that doesn't do the twerky thing, shifting. And then I was noticing the filament was kind of dim in it, so I measured the voltage across it. And keep in mind this is a series set, and I'm only getting 4.16 volts across it. So I stuck the other CRT with the bad DAG in here, and I'm getting 6.2. So this is a factory GE CRT. So this CRT has to have a semi-shorted filament in it. I'm done with these GE sets. I'm done with this junk. Let's do a filament current draw comparison on this CRT and then this CRT right here, which is the one that has the spray paint instead of DAG on the outside of it. But first, let's listen to what I said in the final clip of my last video. I was wondering why this CRT was a little bit on the dim side. This is the good CRT that doesn't do the twerky thing, shifting. And then I was noticing the filament was kind of dim in it, so I measured the voltage across it. And keep in mind this is a series set, and I'm only getting 4.16 volts across it. So I stuck the other CRT with the bad DAG in here, and I'm getting 6.2. So this is a factory GE CRT. So this CRT has to have a semi-shorted filament in it. I'm done with these GE sets. I'm done with this junk. I said that this CRT had a dim picture, and I noticed the filament was kind of dim, so I checked the voltage drop across this CRT, and it was only 4.1 volts. And this being a series string set, that would indicate that the CRT had a semi-shorted filament, and that I plugged this CRT into this chassis, and this CRT had a voltage drop of 6.1 volts or 6.2 volts, indicating even further, confirming that this filament was indeed partially shorted. So to prove this, let's do an actual current drop or voltage drop, current drop test using a regulated power supply set to 6.2 volts. I have this set to 6.2 volts on the 0 to 6 volt 5 amp regulated supply. This is the CRT that I suspect of having a partially shorted filament, and its current draw is 750 milliamps. This is the other CRT that measures the correct drop of 6.2 volts in the circuit, and its current draw is 600 milliamps, 150 milliamps lower. That doesn't seem like a lot, but in a series string set, it's causing a difference of about 35%. And confirming on the 14QP4 data sheet, the filament current is supposed to be 0.6 600 milliamps plus or minus 5%.